Welcome everyone. My name is Akanksha Agarwala and I'm working with Austin Blaze, Nicholas Wong, Rajat Nagavkar and Suryadeep Nalana. This is our final presentation for CS 691 which is deliverable 4 and our application is called Squander. On our agenda, we will have a project overview, go over our project requirements, explain the application design architecture along with technologies used. Next, we will recap all of our sprints, go over the completed test cases, and demonstrate a minimal viable product. Then we will provide a GitHub walkthrough, go over our retrospective, and end with a conclusion. So, before going over the project overview, I would like you all to imagine that you are a working professional and there is some home renovation going in your home. Once the home renovation project is over, you are left with so much of old furnitures like carpets, coffee table, covers, and many more such items which need to be recycled or dumped. But as a professional who is working 9 to 5, it is very hard for you to keep on calling the waste pickup company and schedule a pickup and negotiate the charges, which could be done hassle free and you do not need to stress so much about it. So, our application could be the solution to this problem. You must be wondering how Squander will solve this problem. So, Squander is an image based waste detection mobile application that allows a user to submit an image, which is then fed to a machine learning based algorithm, which then studies the image and determine the kind of waste and segregate the waste into different categories and types. You all must have a question that there are so many different applications available in the market, but why Squander? So, Squander does not require a login page, which allows for a quicker and easier way to get results in your busy life schedule. So, next presenting Surya.
Persona Zil. Zil is a 32-year-old. He's a party host, organizes big parties in the city. He also takes responsibilities of catering in his parties. He has good reputation for providing quality and tasty food to his clients. From the parties he hosts, by the end of it, there is a lot of waste being thrown, being with the food wastage, disposable utensils, decoration materials, waste, etc. Zil is responsible for all these collected waste to dispose it. That's when our application becomes handy for Zil. Squander helps in segregating the waste by categorizing its type with the image he uploads to the application. Then Zil can clearly identify the waste from the results he receives and dispose it properly. And Squander also has a feature that shows the results of the nearest recycling factory locations, where the waste can be taken to the factory outlets that being recycled or disposed in a better way that keeps environmental safe. Simon is a mechanic. He's there in the business from long time. His age is of 35 years. His job is to inspect and repair vehicles. He's a hardworking person and always strives for providing good service to his customers. He works in his big indoor garage with other staff. Every day he gets to repair a lot of vehicles. There are a lot of material waste of metal, copper, plastic being accumulated to thrown out. He always thinks to find a way to sell all the waste from his garage and get some money from it. That's when the Squander application will be the perfect solution for Simon, where the application helps to find the nearest recycling factory and sells the waste to them, which is bought for good price for Simon. The application is very easy and feasible to use for Simon. He doesn't have to worry about the waste anymore, and he also find a way out to get money too, just with the clear direction and information by using the applications. Project requirements. These are the requirement of the project. It is to upload image, detect the waste, and classify it, and receive results. User stories. These are the requirements that Squander provides to the user in the application. As a user, Zil the party host, I want to upload an image of waste item so that the Squander application can provide a camera to upload an image of the waste items. And I want to detect the waste from the image so that I can detect the waste and I can know what can be recycled and what not. And next, I want to know the information that I can obtain from any waste item I might find it, so that I can understand and understand of what waste item are found in the image by classifying the image into its types. Lastly, as a user, I want to receive the results of any waste items found, so that I can get the results of waste items with number of items found. Thus, makes me easy to segregate and decompose the waste properly. Now I'll pass it to my teammate.
Let's look at the technologies used in the application. We have Keras, that's a machine learning framework that's built around the TensorFlow. So TensorFlow provides the basic building blocks that we require to create neural networks. And Keras, what it does to the TensorFlow is create a wrapper around TensorFlow in such a way that we can use those basic building blocks and integrate them to create something fascinating or something new that would work for our application. So the next we are going through the use case of the backend. So why we use the backend was for the integration of multiple applications, multiple endpoints. One of them was to integrate the front-end mobile application to the backend machine learning model and allow it to store images that's used for the machine learning model to validate on. Um, and then we have simple storage services that's provided from Amazon. Simple storage, it gave us a very inexpensive way to store objects and was later used by the machine learning models to create and analyze results based on the images that were stored in the simple storage service. We're also looking for Google Maps integrations that will allow us to provide location service to the users. Um, the Google Maps API would help us in identifying or serving the user with a specific location onto which they could send their recyclables or drop in their recyclables. And the next word we have is the Swift and Caramel. So as you would see, both of them were an iOS SDKs. They are used to create applications for iOS applications. And Swift is a programming language, and that's also object-oriented and similar to Java, that is used to develop the whole application with integrations with Caramel. What Caramel provided was a convenient way of integrating a machine learning model to an iOS application, um, with ensuring that the efficiency of the model has been modulated by the Caramel. Let's look at the architectural design that our Squander application used. So what we focused on was two views towards the application. One was how a user would interact, and what are the balances that we need to keep based on how a user will interact, how the response time of the systems be, and but also ensuring that the security of the users and the security of the backend application is ensured. The other one we looked at was how, as a developer, we could deliver faster products to the user and have the whole workflow of creating a new feature and delivering that to user would flow. So we have the Squander architecture here. Let's look at it from the user perspective. So the user would be accessing our application using a mobile application that's in iOS, and we have used Swift and CoreML to develop that application. Talking about the architecture of the application, we have used an MVC architecture, wherein there is a model view and a controller, and the view gets updated based on the input that the user gave through the controller and updated through the model. The model allows us to integrate multiple logical use cases or logical analysis into the application. So in our case, we have used the model section of the applications to integrate the business logic and the business product. That's the machine learning model that would analyze image for us. So if you look at that, we would see that the model is integrated with a AWS cloud environment. The cloud environment has provided us a very low cost and easily and a faster development cycle for us. We were able to module our machine learning model using a SageMaker and deploy using an Amazon machine learning framework that would host the machine learning model and also allowed us to train and deploy the application. We have also used S3. Amazon S3 is a simple storage service for storing objects, can be of any format. We have primarily used it to store the logs and also the images that the user is validating on. The Amazon CloudWatch that allows us to analyze the logs that have been produced by all these applications and services that we have, and also make sure that everything is running in order as it has to be. So we can create triggers and alarms in AWS CloudWatch to ensure that all the features that we are providing to the user are clean and are up and running. Another main piece of code that we have used is AWS Code Deploy that allows us to fastly deploy all the applications to each resources. We have also used CloudFormation template that allowed us to use an Amazon CLI instead of an Amazon console. So we would have the template written out that would make us easy for all the deployments. Even when we are moving to a different architecture, it's minor changes to the template rather than making a whole new console or a whole new user console for the specific application changes. We have also used IAM. IAM allows the AWS infrastructures to provide authenticity in communication between each independent section of the application. So one of them is the ability for the iOS application to communicate with the AWS cloud. So we have a specific IAM role that we have assigned to the iOS mobile application that allows it to communicate and request for different services provided by our Amazon cloud infrastructure. Now, looking at it from the developer's perspective, you would see that we have used a code collaboration tool, that's GitHub, and each of the code changes comes to GitHub as in forms of commits, and once we have merged all those commits to a main branch, that can trigger a pipeline that has all the necessary features that we need to make sure that the code build was good as we expected. So the pipeline would have stages of test, deploy, and test, build, and deploy. We also have a AWS code pipeline setup that allows us to run the pipeline. Also, we would substitute it with GitHub runners. So the pipeline would later use the CloudFormation deploy to actually deploy the framework as a cloud stack. So those are the two different views towards the architecture.
Hi, I'm Nick, and I'll be talking about our machine learning algorithm. For our machine learning model, we used a convolutional neural network. Our model can take an image and classify it as a type of trash, meaning the model is able to take something like this picture of a plastic water bottle and make a calculated prediction on what kind of trash it is. In this case, it's plastic. The way our model does this is it takes the picture and splits it up into pixels, and each of the pixels are sent to a node in the input layer. And then from the input layer, it passes this information to the hidden layers. And in these hidden layers, there's a bunch of calculations being done in between. And then after the calculations are done, the information gets sent to the output layer. And in the output layer, each of the nodes is given a value for each of the classes. And from there, the model is able to predict what kind of class your image represents. In this diagram, we can see that the model is able to identify 3 different classes, but in actuality, our model is able to recognize 6. Our model is able to classify the trash into cardboard, glass, metal, paper, plastic, and miscellaneous trash. What you're looking at on the right are 9 randomly taken images from a training set, so you can see the kind of images we use to train our model. As you can see, most of the classes we're able to identify are in these 9 images. We have paper, plastic, metal, glass, and miscellaneous trash. All we're missing is cardboard, but you get the idea. Now for the model evaluation. I trained this model for 100 epochs, and you can see how we did. Looking at our validation accuracy, we have about a 75% accuracy to our model, which isn't great, but we're looking to improve on it with different methods in our future sprints. Looking on the left, you can see an example of the input and output that our model produces. With the input of this glass wine bottle, we can see that the model produces a classification, which is glass, and an associated confidence value, which in this case is 100%. So the model is telling us this image most likely belongs to glass with 100% confidence value. And in this case, we can see that the model is right. Moving on to our sprint overview. For our first sprint, we did the foundational basics for our project. We brainstormed and pitched our project to each other, and then we picked on a project idea. Then from there, we decided our team roles, and we set up some housekeeping tools such as GitHub, the Jira, and the wiki page. Looking at our burn down chart, we were able to complete our tasks in sprint 1 in a timely manner. Looking at sprint 2, we were able to further brainstorm and develop our project into something more concrete by creating user stories and test cases. We also did a lot of research in this sprint as we looked into different frameworks for our project, as well as we researched potential machine learning models. I'm talking about mainly the pre-made ones, such as IBM Watson and Google Vision's API. We then took our research and created some mock-up designs for our application, as well as the base for our machine learning model. We maybe planned for too much work in this sprint as we were slightly behind, as the actual trend was higher than the ideal trend for most of the sprint. However, we were able to resolve our work and finish in time for the second deliverable. For our third sprint and our shortest sprint, we did our technical paper. For the technical paper, we reviewed our research for the project, which included all the research from the machine learning models and the recycle facilities, as well as we had to format the paper and actually write it. In this sprint, we did well. As you can see, the actual and the ideal trend are pretty similar. We even finished a little early, as you could see in the end here. Now, in our final sprint, we worked on finishing up a lot of the work required to meet our MVP. We went from our mock designs to a fully developed application, and we also connected the model to the front end of the application so the user can connect with the model and use it. We improved the accuracy of the model by 10%, and we created both of the user and installation manuals. Looking at our burn down chart for our final sprint, We also did a pretty good job with completing tasks in a timely manner, as the ideal and the actual trends are very similar for the most part. Next, Akansha will be talking about the test cases in our project.
Hi, it's me again. So I will be going over the test cases for our application. So the first test cases are for the home screen. So let's go over our first test case. The first test case is to browse the application. The expected result is user should be able to access the home page of the application. And the actual result is once the user opens the app, they are redirected to the home screen of Squander, which is a pass. Now let's go over the second test case is to locate the recycle button. The user should be able to see the recycle button and it should be clickable. The expected result is once the user is on the home screen, recycle button is visible and once clicked on the button, it is redirected to the recycle screen. This is pass again. Now we are going over the third test case, locate the stats button. User should be able to see the stats button and it should be clickable. Once the user is on the home screen, the stats button is visible and once clicked on the button, it is redirected to stats screen. This is pass. Now, we are going to the fourth test case. Locate the contribution button. User should be able to see the button and it should be clickable. The actual result is once the user is on the home screen, contribution button is visible and once clicked on the button, it redirected to the contribution screen and it is a pass again. Now we will be going for the test cases of the capture screen. So here the first test case is locate the camera button. So user should be able to see the camera button and it should be clickable. The actual result is once the user is on the capture screen, the capture button is visible and once clicked on the button, it is open the device camera. This is a pass. Locate the cancel button. So the expected result is user should be able to see the cancel button and it should be clickable. The actual result is once the user is on the capture screen, the cancel button is visible and once clicked on the button, it is redirected to the home screen, which is a pass again. Now, locate the photo library button. The expected result is the photo library button should be visible and clickable. The actual result is once you are on the capture screen, the photo library button was visible, and when the button was clicked, it opened the photo gallery of the device and it is pass again. So now the fourth test case is locate the retake button. The expected result is user should be able to see the retake button after taking a picture of the item and it should be clickable. And the actual result is once a picture of the image or the waist is taken, the retake button is visible. If the user clicks on the button, it is redirected to open the camera again to take the image. And this is a pass again. Now, locate the use button, use photo button. So, the expected result is once the user clicks a picture of an waist, he could either retake it or use the image. So, the use image button should be there and it should be clickable. So the expected actual result is once the user takes a picture of the vase, the photo button is visible, and if the user clicks on the button, it is feed into the model, and this is pass again. Now let's go over the test cases for the stats screen. So again, locate the stats button. So the expected result is user should be able to see the stats button and it should be clickable. The actual results is once the user is on the start screen, the start button is visible and once clicked on it, the button, it redirects to the start screen itself. And this is a pass. Now, on the start screen, locate the household clickable ribbon. User should be able to see the household ribbon and it should be clickable. Once the user is on the start screen, the household ribbon is visible and once clicked on the ribbon is expanded and it contains the detail of households like high-rise society, townhouse communities, individual houses, etc., who have used this application and the amount of waste they have generated. And this is a pass again. Now locate the public place clickable ribbon. The expected result is user should be able to see the ribbon and it should be clickable. The actual result is once the user is on the start screen, the public place ribbon is visible and it's clickable. And once it is clicked, it will expand and it contains the detail of all the public places like hotels, restaurants, etc., who have used our application and amount of the waste they generated. And this is a pass again. Then locate the construction site clickable ribbon. The user should be able to see the construction site ribbon and it should be clickable. The actual result is the users are able to see the construction site ribbon and they are able to click it. Once they click it, the ribbon gets expanded and it contains all the details of the construction places like home, factories, etc., who have used our application and it contains all the details of the amount of waste they have generated and everything. And this is a pass again. Now let's go to the result screen. So here, locate the recycle button. So user should be able to see the recycle button and it should be clickable. Once the user is on the recycle result screen, the recycle button is visible. And when the user click on the button, it redirects them to the recycle screen. Display the waste item list to be dumped. Users should be able to see the list of waste having having values like paper, plastic, metal, etc. And the actual results is once the user is on the result screen, the waste item list is visible and it contains of all the data like paper, glass, metal, plastic, etc. And this is the past. This is pass. And now go to the test cases of display the waste item picture. The user should be able to see the waste item picture. So once the user is on the result screen, waste item picture is visible. That is the actual result and which is a pass again. Now let's go of our last test case which is locate back button. User should be able to see the back button and it should be clickable. The actual result. Once the user is on the result screen, the back button is visible and once the button is clicked, it is redirected to the home screen and that is a pass again. Next presenting is Rajat.
Hello everyone, my name is Rajat Nagakar and I will be showing our project demo that is final MVP. As you can see, Squander app is an iOS app and we have used Xcode as a development environment and we have used Swift as a base programming language. So I will run this application and let you know how the apps works. So so as you can see, this counter app launches, and after the launch, you can see the home screen where in the center there is a earth image, and at the bottom there are tabs that you can use to switch between various screens. The first tab is the recycle tab, which shows is the home screen. The middle one is the stats, which shows the stats um, about the amount of the recycled done by a particular user. And its third one tab is the contribution tab, that it shows about the contribution of a specific individual uh, towards the recycling of items and its impact on the environment. First, if a user has to capture image, he clicks on this earth image, and an alert is displayed, which he it gives two options for him, that either capture via camera or a photo library. So when he clicks on the camera, camera is open. So I will try to detect an object such as glass and try to show you how our model works. As you can see, I have clicked to capture the photo. So here, if we want to use that image, then we click use photo. As you can see, it detects is as a glass with confidence value of 83%. So I will try to detect more objects such as plastic. As you can see, it detects as a plastic and with a confidence value of 64%. So this time I will try to recognize an object such as a cardboard. As you can see, it recognizes as a cardboard and it shows its confidence value of about 97%. So this time, as you can see, I have used flash for capturing the photo. So it depends upon also the light condition, how how the light conditions are there while capturing the photo. Mm, so this time I will try to recognize object. I will try to select the images from the photo library and show you. I have some images from the party stuff such as I'll select this and I'll upload it to the model. As you can see, there one screen is there that it processing screen is there. It process in screen we upload that image to the model and after that in the result screen we get the output of the image. So as our model is as too fast that it takes more like it takes times in milliseconds or sometime to recognize that object. So as you can see here, this party material is recognized as a trash, and I'll try to recognize more objects such as a mechanical stuff that as we have shown in the persona. And as you can see that it recognizes it as a metal. So one more thing is remaining is that I will try to upload an image of a paper. Yes, as you can see, it recognizes as a paper and with the confidence value of 89%. So uh, once the user has got the results of this objects, then he will try to recycle this object by searching the locations that that recycles this item. So now currently we are getting a single output that is recognizing single object. But in the future, but we will that is in the next sprint we will try to recognize more object. And that will give a list of objects, and this list will be helpful in sending that list to the recycling organization or company so that they can recycle and provide a way for its disposal. So thank you.
Let me walk you through the GitHub. So GitHub is a code collaboration tool and version control system that we have used. Right here is the link to our GitHub profile. And what you see here is it's a GitHub repository. We have all the source codes and the project-related files uploaded to the single repository. So during the sprints, multiple engineers would work on the same repository, and we would do code mergers and code rebasing on the same repository. We would also have GitHub Actions, and we have GitHub Projects and GitHub Wiki. The mostly maintained sections of the GitHub is the GitHub code page and the GitHub Wiki page. So with the Wiki page, we have the project description and details about the members that are contributing the project. Also, we are showcasing the technologies that we have used. So as you remember, we have been through this the technologies that we have used in the profile in a different in an application in a different section of the presentation. And we have also uploaded the architecture that the application is using, and we had gone through that before through the slides. And it's the identical application, that the application image that we have in here. Also, we have the project application artifacts. The artifacts include the manuals that the user would be using to install and also to use our application. The installation manual is specific to the developers who would wanna contribute to the application, and the user manual is specific to the user who would be using the application. On the next section, that's specific to the CS691 course, and it contains the deliverables during the whole semester or for the whole duration of the course. At first, we have the presentations. Those are the deliverables that we have presented during the class, and we have uploaded that in multiple formats. We have video formats, we have PowerPoint, and we have PDF formats from each deliverable cycles that we went through. Next, we have the sprint burn down charts. The burn down charts are generated by analyzing the stories that we have gone through at each sprint. So this is a sample of the burn down chart that we have gone through during the sprint 4. So we have the keys for the task written out in here, and then we have a short description. We have the title of the story. We also are mentioning the priority and the completion of it. So right here, you'd see how the time was committed as the sprint progressed, and this is a really good progress by the team. The burn down chart had a similar slope as to that of the expected slope. And then we have the application demo. Here we showcase how the application is intended to be used and what each features means to the user. We also have an appendix of the test cases. So these are the test cases that we have used to test our application throughout the deliveries. Now let's move on to the retrospective, where we focus on what went well through the sprint and what we need improvements on. So at the what went well section, we all agreed upon that our work completion timing was really great. We were able to deliver the deliverables in the time slots that we have committed for. As you would see that in the burn down chart, that we were sticking on to the commitment, the flow, the expected timeline of deliverables. And since we had adapted to most of the collaboration tools, including GitHub and Jira, also we have used code collaboration in other instant message applications. So we came to a conclusion that we had a great communication throughout the team members, and we were progressing, we had a focus point, and we were progressing towards that very well. I would say in union. And what needs improvement, we have analyzed that since the application is was had to be delivered in a short amount of time, we did not have enough time to refactor the code and to reduce the redundancies. So that's something that we need to work on, and we need to spend time to make sure that the code redundancies are reduced. And we have large optimization of the application. The second needs improvement is the user stories and task in Jira. So we find that some of the team members, including the deliverables that were required in the sprint 4, we we did not do a good job in tracking them in Jira, since most of the team members find it easier to communicate over instant messaging than over through Jira. So being a sprint team, we would like those communications to be captured in a single place rather than over a instant message applications. So we are trying to focus on improving our usability of Jira to communicate on the updates of the issue stories that we are working on. So on the future actions, we find that we had a great velocity through the team, and now that we have completed 4 sprints, we would do a great job in accurately estimating a sprint velocity for the coming sprints. And then we also have mentioned, since we need a collaboration, a better tracking, a user's tracking tool, and that allows for faster communication. We also were focusing on a better code collaboration tool that works across the platforms, meaning that any changes, any messaging or any updates that is given in instant messaging platforms are reflected in Jira. We have identified some applications that that would enable us to integrate, and we also are focusing on boards that can update the task for us based on the communication that we have in Jira using a specific format.
Thanks, Austin. Moving on to our conclusion. Squander the application is looking to facilitate the waste materials of users. Right now, the application can currently specify cardboard, glass, metal, paper, plastic, and miscellaneous trash. Our application provides model results, information on the wastage, and the location of the nearest recycling factory. Now, for our application's future work, we're looking to improve the algorithm to detect waste more accurately. And to do this, we're going to increase the quantity of our training data, and we also want to implement inheritance learning, object segmentation, and multiple object recognition. We also want to add more features to the application, such as scheduling and potentially environmental impact tracing. As a whole, we want the application to provide more information to the users, and we want it to eventually recommend recycling locations. Thank you all for listening.